just a quick check, the first few, let's make sure we did them right. So number 1 should be 25 to the x power equals 5. Number 2, 3 to the m equals 81. Number 3, log base 4 of 64 equals x. Number 4, log base 1/2 of 4 equals m. You guys okay on that? Just your definitions. Number 5 turned out to be 1.904. Number 6 we asked about. So, log of 14 divided by 4. So, if I put this on the test, I am fully aware you could plug this in your calculator, but given the information that I've provided in the directions, I'm expecting some work on this. So, what I want you to do is the properties of logs. If you have the log of something divided, how do you break that apart? So we would do the log of 14 minus the log of 4. And then I told you in the directions what I want you to use for those values. The log of 14, I want you to do 1.146 minus log of 4, I told you to do 0.602. So subtract those things and you get 0.544. So number 7, same idea. I expect some work for this. How would I rewrite 56? Properties of logs, if we have things multiplied, we can do the log of each one added together. So the log of 14 is 1.146 plus the log of 4 is 0.602. Add those together and you get 1.748. Number 8 we didn't ask about, but you could rewrite that as 4 squared or 4 times 4 and do the same thing, so it should come out to be 1.204. Alright, I'm just going to give you the answers for the ones that we haven't asked, and then if I need to work it out I can. Number 9 is 1.4406. Number 10 is 0.6644. Number 11 is 3.3476. Those all okay? So we did ask about number 12. Let's work that one out. Okay. We need to use our properties of logs. If these logs are subtracted, how do we put them together? Division. So this would be log base 3 of x squared divided by 7. Then, if you have a log on only one side, what do we do? Then we would just have to multiply over our 7, and this is going to be a massive number. So I have 7 times 3 to the 12. Then how do you get rid of a square? Square root. With that we do plus and minus, but when we plug these back in, the properties of logs have to hold. Can I have a negative right here? No. So it's just going to be the positive, so we've got the square root of 7 times 3 to the 12. And since we can't have a negative, this would be good. Is that okay? Alright. Number 13, you should have gotten 2 answers, 3 and 4 both work. number 14. We have 5 to the x plus 2 equals 7 to the x minus 2. What would we do here? Right. So you add the log, which brings the exponent down in front. Okay, we have to solve for x, and we have more than one x, so we need to distribute our logs so we can get all of our x's on one side. X log 5 plus 2 log 5 equals x log 7 minus 2 log 7. Both of these terms have an x in them, so what should we do? Get those on the same side. So I'm going to add over my 2 log 7 and subtract my x log 5. So we have 2 log 5 plus 2 log 7 equals x log 7 minus x log 5. Then what do? We can't, that'll take us back kind of where we started. We would have to condense them before we could do that. Both of these have an x, so we will factor that out. So then you have x times something, so we will divide. Be very careful when you put this in the calculator. You need parentheses around the entire numerator and denominator, but every time you open a log or you push the log button, it opens parentheses, so you have to make sure and close each of those as well. So if you type it in like this, you should get 21.1331. That one all right? Let's look at problem 15. What do you want to do? Okay. You can start adding your logs to each side, and it will certainly work. But remember, I talked about if a common base is an option, do that. It'll make your life much easier. So I could write both of these as a base of 2. So I could say 2 to the 3rd to the 6 plus 3x equals 2 squared. I'll show you how to do it with logs here in a second as well, but this will just save us time. So we have 2 to the 18th plus 9x equals 2 squared. If you get the same base on each side, you drop it. Subtract over your 18, divide by 9, and you get negative 16 over 9. If you had instead added your logs, you would divide your log 8 over, subtract your 6, and then you'd have to divide the whole thing by 3. you get the same answer. So it does work either way. Just when it works, common base is faster. Is that one okay? 16. Okay, if at all possible, we have to start by condensing our logs. So I have two logs added together. How do I combine those? So I need to do x plus 3 times x plus 4. You can go ahead and FOIL those. Alright, then we have two options. If there is a log on each side, then we can drop it. If it's a log on only one side, we have to change to exponential. What's the base on a log if it's not written? If it's ln, what's the base? Good. So this is 10 to the first. Quadratic, so set equal to 0. Alright, at this point we tried box method. Most of the time I give you pretty nice ones where box method works, but does it work this time? No. So how do you solve a quadratic if you can't do box method? Okay. So x equals opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So that's 49 minus 8, so 41 over 2. Alright, I'm going to convert those to decimals. So if I do that, we get negative 0.2984 and a negative 6.7016. We always need to check and make sure both answers work. When you plug them in, this has to be greater than 0. So the negative 0.29 is fine, but we can't have the negative 6. So our answer is just a negative 0.2984. Is that okay with everybody? Number 17. And make sure if you didn't get these right, make sure you're correcting them and ask questions if we need more practice like something. Okay, can I go through and just drop off all of my logs from the beginning? No. That property, just like when we got solved exponentials with common base, you had to have one base on each side. In order to just drop the logs, we need one log on each side. So first, I need to combine these. Since they're added, we put them together with multiplication. So you have to distribute that x, so that's x squared minus 2x. Now we have one log on each side, so now we can drop the log. So we can subtract our x, subtract our 4, and then what would we do? Box method. Multiply a negative 4 and add to negative 3 would be a negative 4 and positive 1. So we get x to be a 4 and a negative 1. Then we always check Are both answers okay? Not the -1. Remember, if you have logs, every one of these arguments has to be positive, so -1 won't work. So 4 is our only answer. Bless you. Number 18. So can I just go through and drop all 4 of those natural logs? No, we have to combine first. If these logs are subtracted, how do you put them together? So that's x minus 1 over x plus 6. Same thing over here, x minus 2 over x plus 3. Then you can drop the log on each side. What would we do from here? When you do that, you have to FOIL these. So that's x squared plus 2x minus 3 equals, I FOIL those two, x squared plus 4x minus 12. So if I subtract my x squared from each side, that actually cancels. I can subtract over my 4x, add my 3, so I get -2x equals -9, divide by -2, so x is 9. Check 9/2 is like 4.5, so will all of those arguments be positive? Yes. What would you say if one of them wasn't positive when you plugged it back in? No solution. We only had one answer. If it doesn't work, there is no solution. Number 19, you guys didn't ask about, but I just want to clarify. Those are the ones that I told you, if you do not show me work, you will not get any credit for that one. So change of base, you can change it to any base you want by doing log of argument over log of current base. So you would have to write down log of 32 divided by log of 5, and then you can give me the decimal, 2.1534. We had either 20 or 21, but I think I'm going to go ahead and do both of them. We have time. And I know the word problems are sometimes a little bit harder. So number 20, how many years will it take for an initial investment of $25,000 to grow to $80,000? Assume an interest rate of 7% compounded continuously. So I told you all those formulas would be given on the test. Continuous interest is A equals PE to the RT. A is your ending amount. How much do we want to end with? P, principal, starting amount. E is just the button on our calculator. What's our interest rate? And we're trying to find T. So first we divide the 25,000. And that comes out to be a 3.2. We can't get a common base, so we add logs. Anytime you have an E in your problem, I recommend adding the natural log. You don't have to, but it's just a little bit nicer because the natural log and the E cancel each other. So we have the natural log of 3.2 equals the 0.07t. So then you divide by the 0.07. And that comes out to be 16.616, and our time is measured in years. 21. So Maryville was founded in 1950. At that time, 500 people lived in the town. The population growth in Maryville follows this equation. P equals 500 plus 1.5 T, where T is the number of years since 1950. So part A, determine when the population has doubled since founding. So I might say it like that. I might say find the doubling time, just how long does it take to double. If we started with 500, then how many are we ending with? 1,000. So we're going to plug that in for the P. So subtract our 500. Alright, and then we need to add our log to each side because we can't get a common base. When you do that, the T comes down. So we divide the log 1.5. And you get 15.327 years. Part B wants to know, in what year did the population reach 25,000 people? So 25,000 is our P. So if we subtract over our 500, add our log, divide by the log 1.5, and that gives us 24.9. So it did say during what year. We're still in the 24th year, so if this thing started in 1950 and you have 24 years after that, it's during 1974. Okay, we're at the end of the year, but it's still in that year. What if we had several of these like on our homework? I didn't put one on study guide phrase the same way, but what if I said what if I told you to find the doubling time of an investment compounded continuously at 1.25% interest? So doubling time is how long it takes to double. Did I tell you, we're talking about continuous interest, but unlike the other continuous interest problem I gave you, did I tell you how much money you start with or end with? So what did we do on problems like this? Pick up a number, make up a number. So like our P is 10, then our A would be 20 because I wanted it to double. So then we could plug in like that. The R would be 0, 1, 2, 5. Divide by your 10. Add your natural log. And divide. So I just want to make sure you realize if I don't give you the starting amount, you can make one up in a scenario like that. Are we okay with those? So we did not ask about 22, 23. So 22, you should have 2 log base 5 of x, plus 5 log base 5 of y, plus 1/2 log base 5 of z, minus 4 log base 5 of a, minus 7 log base 5 of p. You had 5 different things you had to break apart there. 23, you should have log of x minus 1 cubed times y to the 5th over x times x plus 3 to the 4th. 24, when we're doing those domains, remember the argument has to be positive. So in part A, 2x minus 3 has to be greater than 0. So x is greater than 3/2, so that would be parentheses 3/2 to infinity. B should be negative infinity to 8/5. So make sure you know how to find those domains. Let's look at 25. So the amount of carbon-14 present in plants and animals after T years is given by this equation. If the fossil contains 1/5 of the carbon-14 as its living sample, estimate the age. And I told you your K value. Do I know my A sub 0, how much I started with? No. But I know that the fossil has 1/5 of that. So that would be 1/5 times what we started with. And I gave you that K value, so we plug that in. So then we divide by the A sub 0. Okay, now what? And so then we divide by this. So if you plug that in, you get your T to be 13,235.5 years. Any questions on that? Okay, 26. So this one was the pH stuff. Again, I would give you the formula on your test. You just have to be able to use it. Bless you. So part A, I said find the pH, and I gave you the H3O+. So all you are doing is just pushing buttons on your calculator. It's a negative log, and you type in 1.8 times 10 to the negative 4. And if you do that, you should get 3.7. Part B, this time I gave you the pH. So what should we do with this negative? You can either take it up as a -1 exponent or divide it to the other side. So both ways will get us there. It might be a little faster if we divide it over, if you guys don't care if I do that. Then we don't have to worry about flipping things later on. Then if there's a log on one side, we change it to an exponential. What's the base of our log? So this is 10 to the -8.6 equals the H3O plus. So then if we type that in our calculator, we get 2.5 times 10 to the -9. Alright. 27, just remember when you graph those logs, you change it to exponential form and plug in your points. 28, remember the answer to a log is really just an exponent, so like A is asking 3 to what power equals 81, so that should be 4. B, 3 to what power is 1/3, so that's -1. C, 10 to what power equals 0.01, that's 1/100, so that should be a -2. D, the square root of 6 is 6 to the 1/2, so that should just be a 1/2. E, anything to what power equals 1? 0. So F, we had log base 3 of 27 to the 3/2. So if you get stuck, you could always set this equal to x and work it out, saying 3 to the x equals 27 to the 3/2. If we got a common base, 27 is 3 to the 3rd. Power to a power, you multiply. So we get 9/2. Anything else? We still have about 10 minutes, so if we have more questions or you want some more problems like a particular type, I'm happy to give you some. Sure. Alright, let's look at 23. Alright, so we know, first of all, that any coefficients turn into exponents when we put these things together. We only write the log one time. Basically, anything that's positive goes on the top of the fraction. So the x minus 1 cubed goes on top. This one is subtracted, so it goes down to the bottom. Minus log x, that's subtracted, so the x goes on the bottom. Plus this one, so it's added, so the y with it goes on top. What else? just going to make a problem. I want you guys to try these. So I'll put a couple problems up here. Just grab a sheet of paper or something you can work these on. The domain on the first one. Greater than 0. So add your 4, divide by 5, so x is greater than 4/5. So our answer would be? Good. Alright, number 2, expand. A square root is like what power? 1/2. So we know powers come down in front, so that's 1/2 log base 3 of x. When it's divided, we subtract log base 3 of x squared minus 4. Can you break apart if you have x squared minus 4? Yeah, if it's added or subtracted, we don't break them apart. So we would just stop there. Okay, number 3, what would we do? We have a log on one side, so you change it to exponential. So 3 to the 3x plus 1 equals 27. And then we could do this one with the common base. 27 is 3 to the 3rd. So we subtract the 1, divide, and we get 2/3. Alright, last one. What do I have to do first here? Divide the 0.5. You can't multiply it, so if we divide our 0.5, we get 2, 3x plus 1 equals 0.6 over 0.5, or that's a 1.2 if you divide them. Then what? Add logs. Exponent comes down. So we can divide the log 2. And subtract our 1. We get a negative 0.73696, so that would go to